All right, let's crack the code on data science, but we're going to do it with a bit of a twist. Think of this whole explainer as your ultimate guide to nailing a data science job interview. Ready? Let's dive in.
So let me ask you something straight up. If you had a data science interview, say tomorrow, could you actually ace it? Yeah, it's a tough one, right? But stick with me, because by the end of this, you're going to have a way better shot at confidently saying, absolutely. Okay, so first things first, we've got to get the terminology down. This is the foundational stuff, the kind of questions an interviewer throws at you right away to see if you even know the lay of the land.
And here it is, the big one. This is honestly the first major hurdle in so many data science interviews, and you'd be surprised how many people stumble here. I mean, AI, ML, DS, they all sound kind of the same, don't they? But they're really just different pieces of the same puzzle. So the real question is, how do they all fit together?
Before we dive into all the super technical stuff, let's try an analogy. This one is fantastic for getting your head around it. Imagine a modern hospital, okay? Data science, that's the entire hospital, the whole practice. AI is the big picture goal, maybe something like creating totally automated healthcare. Machine learning, or ML, that's like all the diagnostic equipment that makes it happen. And deep learning, that's the super specialized high-tech stuff, like an MRI scanner, used for the really tricky case.
Okay, so that hospital analogy is great, but here's where we translate it into the hard facts. What I love about this is how it breaks it down. Look at the core focus row. You see, AI is all about making decisions, automating things, but data science, that's about pulling out insights. And here's a huge one. Check out data needs. Deep learning needs tons of data, like massive amounts. But data science can work with pretty much any kind of data you throw at it. So, the big takeaway here, they're not the same thing, but they are all deeply connected.
All right, so we've got the lingo down. Now let's get into the core concepts. This is the next level of the interview, right? This is where they're going to really probe your understanding of the theories that make this whole field tick.
So you've got two main ways of thinking about this: supervised and unsupervised learning. And the real difference? It all comes down to the data. With supervised learning, your data is labeled. You basically have the answer key. You're trying to predict stuff. But with unsupervised learning, you've got a pile of unlabeled data, and your job is to find the hidden patterns, like, say, finding natural customer groups without anyone telling you what those groups should be.
And if that's still a little fuzzy, here's another way to picture it that I really like. A supervised model. That's a student studying for a test with the answer key right in front of them. Easy enough. The unsupervised model, that's more like a toddler who's just been handed a big pile of different blocks. Nobody's giving them instructions, they just have to figure out how to sort them all by themselves.
Okay, and you can bet a classic follow-up question is going to be about this thing called overfitting. Using our student analogy, this is when the student just memorizes the answer key, word for word, instead of actually learning the material. So the model looks like a genius on the practice test, just perfect, but then it completely bombs the real exam when it sees new questions. It's a massive, massive pitfall you have to watch out for.
So theory is great, but it's not enough. What do data scientists actually use day to day to build all this stuff? Let's pop open the toolbox and take a look. And I think this is the perfect way to frame it. Seriously, it's not about being a master of just one tool. It's like being a chef. It's about knowing which tool to grab for each part of the recipe, from chopping the veggies to plating the final dish. You wouldn't try to chop an onion with a whisk, would you? Well, it's the exact same idea here. So here's the breakdown of the essentials. First, you've got your workhorses, your programming languages like Python and R. They're the foundation. Then, you've got your data wrangling tools, SQL, Pandas, NumPy. These are absolutely critical for grabbing and cleaning up messy data. When you found something cool and need to show people, that's where visualization tools like Tableau or Power BI come in. And finally, for the really heavy lifting, for building the actual models, you've got frameworks like Scikit-learn and TensorFlow. And all these tools, they fit into a pretty standard workflow, a kind of pipeline that pretty much every data science project is going to follow. You start by collecting the raw info, then you clean it up, and trust me, this is a huge part of the job, way bigger than people think. After that, you get to the fun part, modeling and analysis, and finally, you put your model out into the world, and just as important, you communicate what you actually found. Okay, we've got the theory, we've got the tools. Now for the exciting part. Let's see where the rubber meets the road. How is all this stuff actually being used out there in the wild to solve real problems? And honestly, this is what makes data science so incredibly powerful.
You're using the same core set of tools, things like regression or clustering, but you can apply them to solve a completely mind-boggling range of problems in totally different industries.
Just take a look at this. It's a perfect snapshot of that versatility. In finance, we're talking about detecting fraud in the blink of an eye. In retail, it's the engine behind every product recommendation you see. Even in agriculture, it's being used to predict how many crops a farm will produce. So this is why it all matters so much. It's not just theory. It has a real, tangible impact, pretty much everywhere.
Let's drill down on just one of these for a second, recommendation systems. You see them literally everywhere, right? So there are two main flavors. Collaborative filtering is basically wisdom of the crowd. It's the whole people who bought this also bought logic. Then you have content-based filtering, which is a bit more straightforward. It's like, hey, you just watched the sci-fi movie, so here's another sci-fi movie. It's all about the item's own attributes.
But look, nailing the technical questions, that's really only half the battle. A truly great data scientist isn't just a math whiz. They're not just a walking calculator. They also have to be a fantastic communicator and a creative problem solver.
And this right here, this is the kind of non-technical question that really separates the good from the great. So you've built this amazing, super complex model. Fantastic. But can you explain it to your boss who has zero technical background? Because if you can't, that amazing model of yours, it's pretty much useless.
This analogy just nails it. Your technical skills, that's what lets you fly the plane. But your non-technical skills, your ability to communicate, to solve weird problems, to talk to the business side, that's what lets you navigate through a storm and talk to air traffic control. A real pro needs both to actually land the plane safely.
Okay, let's start to bring this all home. We've talked about the what, the how, and the why of data science. So what's the final answer? What's the big picture?
I think this captures the two sides of the coin perfectly. The potential for discovery is just immense. I mean, you can find insights, new galaxies of information that no one has ever seen before. But, and it's a big but, it comes with some serious challenges.
And this is the fundamental trade-off you're always dealing with in data science. On the one hand, the pros, you get smarter, data-driven decisions and amazing automation. But on the con side, you're constantly battling the need for massive, clean data sets. You're always fighting the risk of bias creeping in. And of course, there are huge ethical and privacy issues to think about. It's an incredibly powerful tool for sure, but you have to use it responsibly.
And so we'll end with one final interview question. And this isn't just a question to ace an interview. It's really the central challenge of being a data scientist today. This field moves so fast. The tools, the algorithms, the best practices, they're always changing. The learning literally never stops. So if an interviewer asked you that, how would you answer?